Okay, for this example, we're going to look again at the spectrum representation, and we're going to see how you can use superposition to determine what's happening on the output when you're given the transfer function. So what we need to do is to evaluate our transfer function at each of the frequencies given. All right, so first we would have h of 0. Okay, so that would be 1 over 1 plus 0, which of course is just 1. And if we want to have the magnitude and phase, that's of course just going to be 1 at an angle of 0 degrees. Okay, so now we want to evaluate the transfer function at omega equals 10. So that gives us 1 over 1 plus j times 20. Okay, so we want to again find the magnitude and phase of this. So that's just the magnitude of the top over the magnitude of the bottom. Okay, it'd be 1 over 1 squared plus 20 squared. And that's going to give us, which is just going to be 0.05, and the angle at omega equals 10 is just going to equal at an angle of negative 87.13. Okay, so finally we want to do it at omega equals 30, which is our final component in our input signal. So that's going to leave us with 1 over j 60. Okay, now of course we want to do the magnitude and the phase of that, and we end up with 0.016 at an angle of negative 90 degrees. Alright, so now we have each of our input components. Okay, so now we can actually draw the spectra for each, and that will help us find the input. So let's do the DC component, right? So we have Vn, and the DC component is going to be 6, which is what we found in the last video. And for omega equals 0 for our transfer function, our DC component is going to be 1. So in order to find V out, all we want to do is to multiply the input times the transfer function, and that gives us our output. Alright, so for the DC component, we have Vn, we have the transfer function, and we have V out. Okay, so for the next component, we want to do the same thing, and we know that our magnitude of Vn is 3. Okay, and that is at omega equals 10. For our transfer function at omega equals 10, we know that the magnitude is going to be 0.5. And now we just multiply the input times the transfer function, and that will give us the output, which is also going to be 0.5. Finally, we want to do omega equals 30, and we know that the magnitude of Vn is going to be 2. We know that h at 30 is going to be 0.016, and we multiply the magnitude at Vn times the magnitude of h omega, and that will give us V out. Okay, and our result will be 0.032. Okay, so now we've done the magnitude spectra for Vn, the transfer function, and we used both of those in order to figure out V out magnitude. And we're just going to do the same for the phase. Okay, so for the phase, what we're going to do is to draw again the spectra. This time this will be for the phase for all three. Vn, the transfer function, and V out. Okay, so the angle for Vn at omega is 0 was just 0 degrees. For the transfer function, the angle is also 0 degrees. And for V out, we add those together, it's still 0 degrees. Okay, for omega is 10, Vn was at 45 degrees. Okay, our transfer function was at negative 87.13 degrees. And that means our V out would be at negative 42.13 degrees. Finally, at omega equals 30, our Vn input was at 60 degrees. Our transfer function is negative 90 degrees. And our output would be at negative 30 degrees.